Hello, everyone. Welcome back. Today is huge. I'm not exaggerating when I say that most analysts I know believe joins are the single most important SQL topics you will ever learn. Here's the reality. Real databases almost never store everything in one giant table. That would be a nightmare to manage. Instead, data is spread across multiple tables. So customers live in one table, others live in another table, products live in a third table. This is efficient. This is how professional databases are designed. But now you have a problem. The data you need is split apart. Joins are how you bring it back together. So let's get right into it. Yeah, let me explain why databases are designed this way in the first place. Imagine you had one giant table called everything. Every row would have customer name, customer address, order date, product name, product price, quantity, and on and on. How many times would you store the same customer's name and address? Every single time they place an order? That's wasteful. It takes up too much space. And if a customer moves, you would have to update hundreds or thousands of rows. The better way is to split things apart. You put customer details in a customer table with a unique ID for each customer. Then in the orders table, you don't store the customer's name and address again. You just store the customer's ID. One ID instead of 10 pieces of information is much cleaner. But now you need a way to combine them. That's when that is when a join comes in, or that's what a join does. It says take the customer ID from the orders table, find the matching row in the customers table, and bring the customer's name and address along for the right. So that is what a join is. Before we go further, I need to explain two key concepts: primary keys and foreign keys. A primary key is a column that uniquely identifies each row in a table. No two rows can have the same primary key, and a primary key can never be empty or null. The classic example is customer ID. Every single customer gets their own unique ID. Customer 1001 is one person, customer 1002 is a different person, no duplicates, no confusion. Every every well-designed table should have a primary key. You can think of a primary key like a social security number or a driver's license number. It is a unique identifier that never changes and never repeats. Now, going to foreign keys. A foreign key is a column in one table that points to the primary key in another table. Here's how it works. In the customers table, customer ID is the primary key. In the orders table, there's also a column called customer ID. But in the orders table, this customer, this column is a foreign key. That is the customer ID. It's a foreign key. It contains values that match the primary key in the customers table. So if an order has customer ID equals 1001, that means the order belongs to the customer in the customers table where or whose ID is also 1001. So the the order belongs to the customer in the customers table whose ID is also 1001. Now, that's the relationship. The foreign key in one table links to the primary key in another table. This is how tables connect to each other. Let's let's now show, or let me now show you the most common type of join, which is the inner join. Here's the syntax. We are selecting customer name, that is C name, um, dot sales from customers C, inner join, or this 0 on C that's customer ID, what is equal to O that's the customer ID. Now let me walk you through this. Let me walk you through this line by line. First, we write select C dot name, then O dot sales. This is what it implies. I want the customer's name from the customer's table and the sales amount from the orders table. So I want the customer's name from the customer's table, and I want the sales amount from the orders table. So customer's name from customer's table, sales amount from the orders table. The next line, which is from customers C, it implies the main table is customers, which is this. Remember, we always select from table, and we usually select from the customers table. So the main table, this line of code or this line of query, the main table is customers, and I'm giving it an alias of C, so I don't have to type the whole word customers over and over. That is why we use the C here. That is why we use the C there. Then inner join orders 0, which is the next line here. I'm joining the orders table and I'm giving it an alias of 0. O. Finally, on C dot customers ID equals O dot customers ID. This is the matching condition. That is to join the two tables wherever the customer ID in the customers table matches the customer ID in the orders table. So what does inner join actually give you? It gives you only the rows that have a match in both tables. If a customer exists in the customers table but has never placed an order, they will not appear in an inner join result. If an order exists but has a customer ID that doesn't match any customer, that order never or will not appear in um, the inner join results. So inner join keeps only the overlap, only the matches. Now let me show you what left join is. This one is just as important as the inner join. Let me give you the query, the syntax for that. But before that, let me run this so you. Yeah. So we can see our results here. Now let's get into the left join syntax. Let's see. So we select the customer name, sales in the order table. Then from customers, we give it an alias of C. Then we left join. Okay, we left join all this O on this being equal to this. So let me run this in. Yeah, the syntax is almost the same. The only the left has changed. The word left has changed, which is here. It has changed from inner to left, from inner join to left join. But the result is very different. Left join keeps all rows from the left table. That's the table that comes right after from. In this case, that is the customers table. Then it brings in matching rows from the right table. That is the others table. If a match exists, you get the sales data. If no match exists, you still get the customer's name, but the sales column will be now because there's no order to pull data from. So what does this mean practically? If a customer has never placed an order, they still show up in our results. Their names appear, but the sales column is empty. Left join is extremely useful when you want to find customers who haven't bought anything yet, or products that have never been sold, or employees with no sign tax. Yeah. And right join is the mirror image of left join. It keeps all rows from the right table. The table that is the table that comes after the join keyword, and brings in matches from the left table. So the syntax would look like this. Here's an important note. SQLite, which is the database we are using, does not directly support right join, but many other databases like PostgreSQL and SQL Server do support it. Even though we can, even though we can't run it here, you should understand the concept because you see it in other environments. Most of the time, you can just use left join instead of right join by swapping the order of your tables. So right join isn't strictly necessary, but it's good to know it exists. Let me give you a visual way to think about joins. Imagine two circles that overlap in the middle. The left circle is the customer's table. The right circle is the orders table. The overlapping area in the middle is the customers who have placed orders. So like that is the intersection. The intersection is the customers who have placed orders. Inner join gives you only the overlapping area. That is the intersection. Only customers that have placed orders or customers with orders. Left join gives you the entire left circle. Every single customer plus whatever part of the the right circle overlaps. So all customers with order data where it exists. Then the right join gives you the entire right circle, every single order plus whatever part of the left circle overlaps with it. So all others with customer data where it exists. If you can picture those circles in your head, you understand joins very well. You understand joins very well. So we just take it as two circles that are overlapping, and their intersection is the inner join. The entire left circle with wherever it has intersected the right um, circle is the left join. The entire right circle with wherever it has intersected the left circle is the right join. That is basically it. You probably notice that in my examples, I wrote uh, customers C, I wrote customers C, and I wrote others who instead of writing out the full table names. Those are called aliases. Instead of typing customers, customers customers dot customer ID. Hold on. Instead of typing customers dot customer ID, then others dot customer ID, and I just write C dot customer ID. I just write C dot customer ID. Instead of others dot sales, you just write O dot sales. It's cleaner, it's shorter, and it's easier to read. You can use any alias you want. Customers cast works. Customers E works. The letter C is just it's just a common choice because it's the first letter of customers. One important rule you must take note of is once you define an alias in the from clause, once you define an alias in this from clause, you have to use that alias everywhere else in that query. You cannot switch back and you cannot switch back to the full table name. So be consistent. Before we wrap up, let me introduce you to subqueries. Let me introduce you to subqueries. So a subquery is a simple query inside another query. You can use the result of one query as a filter or as a data source for another query. Here's an example. Let me go back to our DB browser and show you something. So assuming we select everything from our orders table where our customer ID in select. Let me write this quickly and explain. Customer ID for customers where region was let's say voter, and we close brackets. Let me run this before we give the explanation. Yeah. So let me explain what happens when you run this code. First, the database runs the inner query. That is the one inside the parenthesis, which is this. It runs this. That query says, give me all my customer IDs from the customers table where the region is voter. Give me all my customer IDs from the customers table where the region is voter. The result of that inner query is a list of customer IDs, something like 1001, 1005, 1012, then a whole lot of just 1, 2, 3, 4, or 9, just customer IDs. They are integers, they are numbers, or whatever the IDs are, and so on. Then the database runs the outer query. It says, give me all rows from the orders table where the customer ID is in that list. The result is every order placed by the customer or every order placed by customers who live in the voter region. You could achieve the same thing with a join, but sometimes subqueries are easier to read or easier to write, especially for more complex logic. So subqueries are powerful because they let you use the results of one query inside another query without having to run them separately. You don't have to run one query, copy the results, and then paste them into a second query. The subquery does all of that automatically. It does all of that automatically. So you can use subqueries in the where clause, like we just saw. You can also use them in the select clause to calculate values or in the from clause to treat a query results like temporary tables. And as you get more comfortable with SQL, subqueries will become a valuable tool in your toolkit. Before I send you off to practice, let me warn you about the most common mistakes or the most common join mistakes beginners do. The number one mistake is messing up on the on clause. If you join on the wrong columns, or if you forget to specify a join condition entirely, you can get duplicate rows. Lots of them, like you can get lots of duplicate rows. I'm talking about the I'm talking about thousands or even millions of duplicate rows. Like you can just get them like that. This happens because without a proper on condition, the database matches every row from the left table with every row from the right table. That's called a Cartesian product. If you have 1,000 customers and 10,000 others, that is 10 million rows. Your database will slow down or crash. So always double check your on clause. Make sure the column names are correct and the relationship makes sense. The second most common mistakes is forgetting to use table aliases for ambiguous column names. If both the customer's table and the others table have a column they have a column named customer ID. You have to specify which table it comes from. Write customers dot customer ID or C dot customer ID. If you just write customer ID by itself, SQL won't know which one you mean. Mhm. So always be explicit. Now let's turn to your practice. Here's your assignment. You have two tables, customers and orders. Write an inner join that shows customer names and their order sales. Only customers who have placed at least one order should appear. Second, write a left join that shows all customers, including those without orders. For customers who, for customers with no orders, the sales column should show now. Then third, use a left join to find customers who have not placed any order or any others. Think about how you would filter for null values. Finally, write a subquery that finds all orders placed by customers who live in a specific region. Pick any region you want. Take your time, write each query, run each query, and look at the results. And also make sure they make sense. That is the important thing. If you get stuck, scroll back at or scroll back through this session. Everything you need is right here, or you could put your questions in the comment sections and we'll get to you. So that is it for section 9. Joins are a big topic and they take practice. Don't worry if it doesn't click immediately. Run some queries, make some mistakes, break things, and fix them. That's how you learn. Next session, we are going to combine everything we've learned: SQL plus Python plus pandas plus visualization. That's the final piece of victory. So see you there.